This video was brought to you by a ABRP planner, Kempower, Markus Bil, Stormberg and Bilkomponenter. Yo, what's up? We are now sitting in an electric bus and I'm actually doing a 1,000 kilometer challenge right now. And with me today I have Michael from, in English we just call it the Eurabus.
Yep.
But in Deutsch it's called
Eurabus.
Eurabus.
Yeah.
Yeah, Eurabus.
Yeah.
But I separate this out from the 1,000 kilometer challenge because otherwise it would be too long, the video. But I just have some questions, and I think also many of my viewers would have the same questions. So let me see, where to start. So this bus we are sitting in right now, it's just a short bus, and maybe some people might get the wrong impression that, you guys only have this electric small bus. Well, you have bigger buses, right?
Yes. So this is just one example, a demonstration vehicle for the European customers. Because in the past we very often had the 12-meter buses. That's standard size for typical buses. And then customers came to us, yeah, we know that you can do 12-meter buses. Can you also do short buses? So this bus, when we started to decide to build it, we said, okay, this time we make a short bus, which is 8.5 meter. And yeah, now people are asking, do you have big buses? So whatever you do, it's not the right one.
So with this one here, the short bus,
yeah.
How big is the battery?
This bus is right now equipped with a battery of 268 kilowatt hours. And out of this, 215 kilowatt hours are usable.
Okay. And then how fast can it charge then?
It can charge with 450 amperes, which is roughly 250 to 280 kilowatt, depending on the voltage of the battery during the charging curve.
So it means that actually for the 1,000 kilometer challenge we are doing now, it's not even the fastest bus. Because Michael, you said that you actually had a better one that was not available.
Right. So the best bus we could do this challenge is our big long distance coach. It has a very large battery and can charge with more than 300 kilowatt per gun. We could also use a double gun charging, then it's 600 kilowatt. And the battery can be up to 1,000 kilowatt hours. So there's nearly no charging. It's only going to the toilet and changing the driver. And just driving the 1,000 kilometers.
Well, you mentioned the double, what was it again, the double
gun charging.
What?
So we have the option, if customers are asking for it,
two plugs?
To double the charging speed by using two guns.
You can double penetrate the bus with...
Yes.
But how does it handle it when you have two inputs? How does the BMS handle it? And what about the current?
Yeah.
You have one battery pack.
Yes.
But then two inputs.
Yeah, so it's just making a total maximum charging current that is allowed, and then to both the chargers, while we have a lot of charging current available, is telling them 50% each, and at a later point of time one of them is just skipped, and then the single gun is handling the rest of the charging. So this is quite easy. But this is not a setup, let's say, for buses driving around with no specific depot. This is typically used on a depot with the same charger every night. So it's a very special customer thing, but some customers are asking for it.
But you don't split the battery in half or something like that?
No, because many components need a single source of power. And so I cannot decide the air conditioning is running on this, the motor on this, the compressor on this. So it's just one big high voltage system, and that's fine. Okay, well, of course,
for the charging. Wow, so it's only, wow, okay, interesting. And then, yeah, what else is it? This is a short bus. Oh, sorry, it's a bit shaky right now. Maybe because the road is a bit bumpy.
Yeah.
Yeah, so, where is this bus manufactured then?
Yeah, this bus is manufactured in our main plant in China. All the development was done in Germany, together with some other European suppliers. And the assembly, the building, the welding, the metal things, this is all done in China, in the south of China, in the Hong Kong Bay area.
So they are fully assembled there and then shipped here, or how does that work?
Yes. So if the customer is asking for a complete bus, it's completely assembled and tested and validated and homologated there, and then put on a ship, like a big ferry, coming to one of the northern coast ports here in Europe, and then driven on the road the last piece of the way.
And then, especially now you're doing this 1,000 kilometer challenge, what is the energy consumption for typical, well, this one will be for city driving?
Yeah, so we have two energy consumptions that we typically say. There's one just for the pure driving, and then a second one for heating or cooling. The driving one depends on the vehicle size and the topology of the customer profile. For our 8.5 meter today, it's about 0.7 kilowatt hours per kilometer. And for the heating and cooling, we have to do a simulation because each customer is running on a different operation hour. Some are doing like 16 hours per day, others are doing in the morning 4 hours, in the evening 4 hours for school kids. Some are operating on very warm or very cold areas. So there's no statement I can give as a fixed number because every customer is different.
Okay.
Yeah.
But that was the city. But what about the what do you call it, the coach bus or the long haul?
Yeah, the long distance coaches. They typically need 0.8, 0.85 kilowatt hours per kilometer. So only a little more because they don't have the stops all the time. So it's a very continuous driving, and this is also energy saving.
Well, are those the big buses, or how long are they?
The coaches typically start at 10 meter, so this is a very short coach.
Okay.
And the most of them is 12 or 13 meter, and the very few ones are 14 or 15. 15 is by the homologation limit in Europe, the maximum. Most customers have 12 or 13 meter buses.
But is that how many seats are you talking about then?
This depends on the, let's say, star or VIP rating, how many seats the customer would like to offer, how many legroom. So the 12 meter bus is between 38 and 45 people, sometimes 50. If you want to do the Ryanair chairs, it's a customer thing.
So it's a full-size bus, basically?
Yeah.
Wow. And you can go really long.
Yeah.
You know, as an example, in Thailand, from Bangkok to Chiang Mai, that's a 700 kilometer loop.
Yeah.
And with a fossil tour bus, they usually stop halfway for about an hour just for the passenger to eat.
Yeah.
But you could even go that one non-stop.
Yes. Yeah.
That's crazy. So the technology is already out there and it's available and you can buy it today.
Right. It's not future, it's just existing technology.
And then how long do you have to wait if the customer orders one today?
Yeah, it depends. If it's a completely existing design and specification combination, it's about 6 months, which includes 2 months just of shipping time. If the customer has requirements that we need to modify something, then it takes a little bit longer. It depends on how much impact he wants to have.
Okay.
So this is, you have to know that at least in Europe, each city bus is unique. So you will not find a second bus with the same equipment and the same specification in a second city. Every city is doing their own bus.
Well, I just have to wrap my head around this. So if the buses can already go 1,000 kilometers or 600 kilometers, why are they not being used more in long trips?
The problem at this point right now is the charging infrastructure. So if you're running buses in a city bus operation, you have your depot in the night, you have a fixed charging spot, everything is fine. On the long distance, the bus has the same problem like a truck. We are just very big, and we will see later on the charging stop that some of the now big charging parks, they have drive-through lanes like for trailers, for passenger cars with trailers. This we can also use. But if you have more bus and trucks, this will be just not be enough. So right now we see that the charging parks are set up for large vehicles, also with the new charging gun. So buses and trucks will have more faster, more powerful charging gun. And then this bottleneck is solved, and then the suppliers will bring a lot more vehicles to the road. Right now we see the long distance coach only if you have a specific application. This means you drive every day the same route, for example from Bergen to Oslo and back, and you can charge in the night on your depot or whatever. Or for example, if you do like VIP tours around Berlin or Geiranger Fjord from the cruise ships, you unload the people, drive them to Dalsnibber and back, something like this. So this is possible. The customer that has travel groups, like the school kids going to the north on one day and then the seniors going to the Alps on the second day. This is very challenging right now, and I don't see this as an application in 2023, but maybe in 2 years.
Oh, okay. Yeah. But wow, so they can actually go far. But so I'm wondering, investment price here. This one must be more expensive, but right? Is it? I mean, in percentage, how much more expensive is it than diesel?
Let's say the initial price is about double. It depends a bit on the market and the configuration, the battery size. But let's say it's about double the price from a diesel bus. But you save on the TCO, the total cost of ownership, and then it will pay off very soon. Some countries offer subsidies, then it's even faster. But the original price is about double from the diesel bus.
Okay. But then there are, I mean, we should know it by now that electric cars, or even buses, they are way cheaper to run.
Yeah.
So if we try to break down that, for example, we mentioned the consumption was 0.7 kilowatt hour or 700 watt hour per kilometer. How to say, man? That is very efficient. As a side note, I used to drive my Model X and a trailer, which is way smaller, and it usually consumes around 350 to 400 watt hour per kilometer. And here we have a freaking bus. But okay, but when it comes to price, so if it's 700 watt hour per kilometer, and then what is the electricity price in Germany, for example?
Yeah, it was very high last year, and now it's coming back to around 30 cents per kilowatt hour.
Okay.
So new contracts are signed around 30. So you have a 100 kilometer price of about 21 euro, or per kilometer 20 cents.
20 cents per kilometer?
Yeah.
And then versus diesel?
Yeah, diesel bus usually, it also depends on the size and the road and everything, needs about 30 to 40 liters. Let's say 30 liters as the comparable value for today's run. And if you count the diesel price from €1.50, it's about 45 euro or 45 euro cent per kilometer.
Okay, so double. Yeah, so already there we save money per kilometer driven.
Yeah.
But then what about maintenance?
Yeah, maintenance is a very big point on the diesel bus. You need a lot of filter changing, oil changing regularly. Those parts, same on the passenger electric cars, is just not existing. This means the price for the maintenance is very low. There's a few liquids you need to change after a few years, or based on mileage. Some air filters which is not drivetrain relevant. And yeah, for sure tires, doors, so stuff that are used also on the diesel bus. But the pure drivetrain is nearly maintenance free.
And then how often do the diesel buses need service, the service interval?
Yeah, they also have small and big ones as far as I know, so I'm not that diesel expert to be honest. It's about, I think the small one 10 to 15,000 kilometers and the big one 20 to 30,000.
Whoa, that is often.
Yeah, but it depends on the brand, so as I said, it's not my perfect knowledge.
Well, but it sounds to me like diesel buses, they need service monthly.
Yeah.
Something, or maybe even more often.
Yeah.
But then what about the electric? Then how often do they need to go in for service?
Yeah, as I said, for the drivetrain it's maintenance free. So there's just the system will check itself. When there's a problem, it will tell you check this, check that. We call this predictive maintenance. So the computer is collecting all the values and deciding based on fleet experience, this one doesn't look okay, please have a look on it before it breaks down on the road. Yeah, that's it. So there's no regular service like this, like you know from the fossil car, fossil bus.
And then, well, I can't show you guys right now, but for the driver's perspective now, you know you have the what do you call it, the recuperation stock.
Yeah.
But does it just look and feel just like a regular bus for the driver? They don't need any special training, do they?
Yes, they need a little bit of training to do this. Or what is the English word? If you drive very carefully and you look long on the distance and
like
decide to drive smooth. This one, they need to keep in mind a little bit more that this is way more efficient than just driving like a piece of wood with full throttle and full braking.
Okay.
On the other hand, all the operation is like a regular bus or old bus, let's call it like this. Since we have no gearbox, we have no vibrations anymore, no gaps between the gear changes, so it's not like doing like.
So is it just single gear?
Yeah, it's a single gear.
Oh, okay.
So they are very happy about the smooth driving. Yeah. And what we notice, for example, on the highway driving now with this bus, if you have very steep hills, you know, from the fossil trucks, they have to shift all the time. Every time they shift, they have no torque, and so they will get slower and slower and slower. Our bus is just driving, is overtaking them, and you have no loss of power, so it's incredible how fast you can overtake.
Yeah, I noticed that we have another driver here driving for us, and he hammers it like a typical German driver, and he has that punch just like the buses in Oslo, I noticed. So when it comes to more spec, but I forgot to ask some of the specs. So where is the motor placed? We are sitting a little bit in the back now.
Yeah, so the motor is right below us. It's behind the rear axle. In this bus we have some stairs because it's too short to cover all the technology. If we have the 12-meter buses, they are completely flat, and then the motor is shifted below one of the seat rows, so it's still a piece of central motor, and then with a drive joint which is having two joints to come in line with the axle.
Okay, so but this is okay. The drivetrain is roughly beneath us here, right?
Yep.
But where is the battery located then?
Yeah, in this bus we also ran out of space, so half of the battery, 4 battery packs are on the roof.
Oh!
Yep. 2 battery packs are below us, right and left, and 2 more are in the front.
Okay. And then you mentioned, well, when we talked earlier, it's LFP battery, is it?
Yes.
Okay, LFP battery. But how does that affect the handling if you have a battery on the roof?
Yeah, that's a good question, a very often asked question. Then I say, imagine you have the classic double deck bus. On a double deck bus, you have 50, 60 people in the second deck. Each person on the average of 70 kilograms, typically more. So it's a lot more weight than we have on the battery. So yes, you feel something, you have to do something with anti-roll bars, with adaptive damping, with ESP or ESC, which is serious in our buses. But it's not that big problem. So yeah,
okay.
It's just an engineering challenge, not a big thing.
But for this one, the short one, the 8.5 meter, how big is how heavy is the total battery? Pack?
Yeah, the total battery pack here is about 1.6, 1.7 kilogram.
Oh, tons. Or
Ton, yeah, sorry.
1.7 tons. That wow, that wait, 1.7 ton for 280.
68.
Yeah. Wow, and that means that roughly 600 kilograms is on the top. But then, do you know the empty, or what do you call it again, the weight, the dry weight over there as well?
Yep, so the total empty weight for this vehicle is about 10 ton.
10 tons?
Yep, quite on the spot, 10 ton and 20 kilogram or something. When we measured it.
So which means that most of it is in the back, in the low end.
Yeah.
So just adding 600 kilograms on the top shouldn't affect the consumption. I mean the handling that much.
Yep. You also have the air conditioning on top with another 300 kilograms. So let's say with the batteries, it's a little bit more than 1 ton on the roof.
Okay. So it's somewhat common to have that on regular buses anyway.
Yep. So all the electric bus manufacturers right now do their design with filling the roof first, and if this is not enough, they fill the rear end. It's not unusual to have up to 3,000 kilograms on the roof.
What?
Including the air conditioning, yeah.
What? Huh? What do they put up there?
Yeah, 600 kilowatt hours. Some of them 500, 600, yeah.
Okay.
So the very big buses. So this is technically possible.
Yeah. I think the buses, I mean, they're not supposed to go too fast around curves anyway because of the passenger comfort.
Right.
So
Yep.
Wow, okay. Well, interesting. I'm not sure. There were some other questions. Yeah, so maybe some people want to know also about how strong is the motor here?
Yeah. So in this bus, since it's a demonstration bus, we had to decide what do we want to show the customers. Do we go to mountain customers? Do we go to flatland customers? We had to find a compromise. So this bus is equipped with a motor with 265 kilowatt peak power and 190 continuous. And the torque is, I think, 1,500 Newton meter before the static gear.
Wow. That's massive.
Times 6, so around 9,000 Newton meter on the wheel.
Wow. So compared to, for example, typical passenger cars, they will have roughly 300 Newton meter torque with around. So that means that this is massive torque.
Yeah. But we are heavy.
Yes.
Never forget we are heavy.
Yeah.
And even fully loaded with the people, we have to start on the hill, and so we need this backup.
Yeah. And then, do you know also about the weight distribution between front and rear axle? Is it more rear heavy or front heavy? Or?
If we are empty, so without passengers, we are more rear heavy. And if we're
good.
fully filled by the defined number of passengers, it's quite equal.
Okay.
Yeah.
But also, so it's rear-wheel drive. Is that common for buses to be rear-wheel drive?
Yes.
Okay.
Yes.
And then I've seen some rare cases in Norway. Some buses get stuck in winter, maybe. But it's all about the traction and good tires.
Yeah.
Right? And
Yeah, so there are two options. If you have an articulated bus, so with the bending piece in the middle, you could install two motors on the two rear axles, and then you have like not all-wheel drive, but two-axle drive. This helps a lot in Scandinavia, as we know. And if you have a single axle, single drive, then you have to set up the snow chains at a certain point of time. But normally it's not that big issue.
Okay. And then when it comes to the motors, they will generate some heat. Do you have some heat scavenging? Because in winter, I know that you need lots of heat for when people open the doors.
Yeah. So at first we don't have really much heat because the motor is running so efficient. And that little heat that we have, we can put into our heat pump system, and then we use it to support and increase the COP of the heat pump.
So yeah, you're doing something similar to Tesla.
Right.
Yeah.
Not that perfect, not that fancy, but the basic idea is also here.
Okay. And then also I forgot to ask you, the battery pack, is it also actively cool?
Yeah.
So it means also the roof part, there needs to be called a cooling loop to the roof.
There's a lot of cooling circuits in this bus, so we have 4 cooling circuits. One is for the battery, one is for the traction motor, one is for the passenger heating, which we have the sidewall heaters here, and one is for all the other electronic devices, because all of them are running on different temperature levels and you cannot combine them. That's why we have 4 different cooling circuits.
Wow, yeah, but okay, lots of technical questions. Yeah, is there something else you want to add, by the way?
Good question. Yeah, I'm very happy that you are here today, that we can finally do the challenge. And I'm also looking forward to the result, because we have perfect conditions today. It's about 20 degrees, it's not very windy. So let's see if we can beat maybe the 13 hours, including the charging sessions, and see how much time we need compared to a diesel bus, because the driver also needs to rest, and then we will see how much slower the electric bus is on the long distance.
Oh yeah, can you by the way repeat the rules for the resting and driving in Europe?
Yeah, there are rules that the driver has to take a break after latest 4.5 hours of continuous driving. He has to stop for 45 minutes. This can also be split into 30 minutes and 15 minutes. This is what we are going to do today.
Because of the challenge.
Yeah, because 4.5 hours would mean 450, 500 kilometers driving. This is something we cannot do by the battery size of this bus. That's why we use the second rule of 2 smaller brakes. And so we will do smaller brakes all the day. Go back and forth, do the charging, and then just see how much additional time we need to the regular stops we anyway have to take.
But also, you should know all the rules about this, right, Michael? But when you are, truck drivers, when they stop for the break, legally they are not allowed to work. They cannot even tighten the straps or do work. Yeah. But charging, is that counted as work when you plug in? Yeah. Or how is that?
Yeah, as far as I know at the moment, this is an unsolved problem because the moment you charge, you connect the gun. This is for sure working time.
Okay.
But then the vehicle is charging itself. You don't have to supervise it. So from the view of a normal thinking person, I would say it's not working time. But we have to have a rule for that, an official law. But since more and more electric vehicles will come, they will modify this and adapt it to real life conditions.
No, because when you are refueling, that is working time, right?
Yeah.
I see.
Yeah, you have to supervise it. When suddenly the fuel spills out, you have to act, you have to do something. If the charging gun is not working, nothing will happen.
Okay. But I also noticed, by the way, that you have a regular AC charge port with a DC.
Yeah.
So how fast is the AC onboard charger in this bus?
Yeah, this is also equipment for our demonstration vehicle, since we never know where we can charge and how we can charge at the customer. So we installed two 22 kilowatt onboard chargers, a total of 44.
Okay.
Where we can use all the old triple chargers, which you still find on some places. You can use a classic wall box with 11 or 22 kilowatt. So we are maximum flexible with this bus. The customer on a regular order will decide if we use just an 11 or 22 kilowatt charger or 44. Maybe he can also decide for the slower fast charging. If he doesn't need the quick one, because you need thicker wires and some adaptions. So this is like Lego pieces. Whatever you need on your order, you just pick it and select it.
Okay, but you guys probably have some competitors also. For example, VDL, they have buses, right? And
Yep.
also BYD in Oslo, they use also BYD.
Yes.
So how is the Eurobus compared to the competitors in the market today?
Yeah, this is a good question. So where are we in the market? We see ourselves in, let's say, in the middle. So we are not complete Chinese. So let's say like BYD, like Yutong, those pure Chinese people, they also adapt to the European market needs more and more. Then you have the old European ones with the European style and everything, but
Mercedes,
very expensive.
Oh,
we try to be in the middle. So having the advantages of the German engineering, but also with the Asian production facility, and offering the European mindset for the software, for the service, for the after sales. And this is the niche which is big enough, because you have to know, in Europe, all the city buses need to be replaced by latest 2030 to emission-free, which will be at the end of the day 99% battery and a fuel cell and everything. And this is about 70,000 buses. And so there's no market. The market is so big that everyone can supply, and still everyone is happy. Because a single player or a few players cannot feed the market, it's too big.
But then you mentioned emission-free. Well,
Yeah.
you guys could, I mean, in Germany, what was it, Europe or Germany, the 2030?
Complete Europe.
Europe.
Yeah.
But why don't they go for hydrogen?
Yeah. Let's say it's a few cities do this, to be honest, because of political reasons, because of subsidies and lobby work. But all the cities that have to calculate and pay for their buses, they go for battery electric because it's much more cheaper, it's more efficient, and also the TCO is a lot better on the daily driving, the refueling. And there's one thing that many people don't know: this fuel cells have a lifetime just by operation. It's between 5,000 and 8,000 operation hours, still increasing because they also do some development. But this means in a typical bus operation time, it's 1 to 2 years, and then they have to replace the complete stack for a couple of 10,000 euro as additional maintenance cost. So the fuel cell bus will never pay off by operation cost, and it's not really going a longer distance than a battery electric bus because the battery capacity increased so much, and we do the same 400, 500 kilometers if necessary. There's just no advantage, no reason to go for hydrogen.
But also, when you mentioned the maintenance, so that was you have to replace the whole fuel cell.
Yeah.
But also, you need to change the filters. The filter needs to be super clean.
Yeah.
Yeah, and also, Toyota or those passenger cars, they need maintenance every 10,000 kilometers only. It should be the same for buses.
Should be the same, but to be honest, I'm not that deep into this. Since 2018, we decided not to follow this path, and then we stopped investigating it because none of our customers is asking for it.
Oh, okay. So it seems to me like hydrogen buses might be at the end a very bad idea, economical wise.
Yeah.
Because I hear from my followers, they always say that, well, hydrogen doesn't make any sense for personal transportation, but for businesses, for long haul trucking or something, it will make sense. Well, does it make sense? Even for trucks?
No, because the battery development was so fast that every time we thought the fuel cell might catch up the disadvantages, battery made the next big step. and so there's no reason anymore. And if you see the new charging standard for the battery electric commercial vehicles, will support up to 3 megawatts, 3,000 kilowatts of charging power.
Whoa!
And if then have a 500, 800, 1,000 kilowatt hour battery in your bus or truck, which is, as I said, our coach does have it. If you look to the Swiss guys from Designwerk for the trucks, they have 900 kilowatt hours in their truck, and then you charge it with a couple of thousand kilowatt from the gun. You are ready in the 45 minutes driving break to go for the second shift of the day. So there's just no reason anymore for the fuel cell.
Yeah. Wow. Okay. But also when it comes to charging, by the way, I should mention that I look at Wildbike. You know my 1,000 kilometers. Yeah. And at Wildbike, Circle K, they're building a truck charger there. At least, I saw some. There was some ABB, probably 350 kilowatt. But does that mean that it's not only for trucks, buses also, or can buses also charge there?
The idea, what I know, is for the trucks and buses to have their own charging lanes at least, because the people running trucks and buses, they are doing this for business and not for holiday. And if they are parking and have to wait for the charging spot to be free, it will cost money.
Yeah.
The money the customer has to pay. And so the idea is to reserve lanes exclusively for the big vehicles, so that no, let's say, Volkswagen e-Golf with 40 kilowatt fast charging is blocking their lane. That's the idea behind. And on the other thing, what you also may have noticed, that the bus and truck, the big ones, need a lot more space to enter the area. And they also just need a different layout for the stalls.
Yeah, well, it's. I think the future is looking bright, and I think already that it's not even the future; it's already now here.
Yes,
it exists. It's just that customers, they haven't realized it and haven't started using them.
Yep.
So that's what this video is all about: is to try to make it more visible and to answer some of the questions. Maybe some people are sitting, they could make the decisions, but they just don't know that there is a good solution out there.
Right. Yeah. And then the good thing is on electric, we can simulate everything. This means we have a computer-based model from this bus, and if the customer is giving us his inputs as good as possible for the specific route, whatever weather conditions, we can tell him by a few percent exactly what will be the range, what will be the cost and everything. So before signing the contract, he knows what he's doing. And this is helpful. If you have to make a decision, you're not sure, you want to have like a backup for your decision, we can offer this.
And I should also mention that in Oslo, municipality in Oslo for local driving, they have plenty of electric buses. I should make a video about that. Yep. So many buses, but they're mainly BYD and VDL I've seen with the pantograph. You also offer the pantograph, or how is that?
No, we don't.
You don't?
No, pantograph is a very special thing because it's not just like an additional charging source. It's a complete different configuration. So the pantograph needs some space on the roof, and you need batteries that really can support fast charging, a lot more than 1C. It's like 5C and sometimes even more. Those batteries, they will not last that long by design. It's part of the complete vehicle operation strategy. You need to set up the pantographs. We hear from a lot of drivers that they have problems hitting the station, and it's a lot of stress for them. At the time when cities like Oslo decided to make this, the big batteries were not that available, not that easy. So they had no choice. If they want to go electric at that time, especially in your winter time with a lot of heating, it was the only choice. Nowadays, batteries are big enough, cheap enough, that we can do the same things with the battery electric buses, full battery, with the depot night charging. But if a city once decided for the pantograph thing, they invested in the infrastructure, so they have to follow this path for some time. Otherwise, they burn money twice.
Okay. Just remember another thing. Sorry, I don't have a script, but I just ask as we go.
Yeah.
The pantograph solution, how much extra weight does it add on the roof?
I have to look up the data sheet, but it's not that much.
Okay.
So there are two types of pantographs. One is coming down from the infrastructure to the vehicle, then you only have some like bus bars on the vehicle. This is very lightweight. Or you have the pantograph on the bus connecting the infrastructure, then it's a bit more, but I have to check, but my guess is at 200, 300 kilograms, it's not that big.
No, okay. Yeah, but it still adds weight up there.
Yeah.
But it sounds to me like if you already have a mega charger cable or something, or just CCS2, you can even get a long way with that.
Yeah.
It seems like the limitation today, by the way, for CCS2, well, it might even be more than 350 kilowatts, because if you have a 900 volt battery pack times it's 500 amp, right? That's roughly 450 kilowatt even.
That's true. So, and here we have another limit right now, that if you have a battery package with that high voltage, all of your components, the traction motor, air conditioning, the air compressor, the steering pump, they all have to run on this high voltage. And most of the right now existing components are limited to 600, 700, 750 volts. And new development for the bus market is too expensive, because we only have small numbers compared to the trucks. So we have to stick on the available components, and that's why we have here 600, 650 volt typically in our buses. The new charging standard, the MCS, the megawatt charging, will go up to 1200. Then anyway we have to make a development, and we can adapt, but only for this additional 100, 200 volt. Nobody is spending money right now.
Oh, I see. Okay.
Yeah.
Well, all right, but that was a lot of questions. A very interesting discussion about Eurabus.
Yeah.
So, do you guys also have YouTube account or something?
I think yes.
Okay.
Yes.
Yeah. So that means that if you guys have more questions, you can just comment, and then the Eurabus people will answer.
Perfectly. And my colleague will follow up with this.
Yeah. And maybe I'll put the website in the description or something like that.
Perfect.
So I think we have to go back to pay attention to the 1,000 kilometer challenge now and see how fast it will do it.
Yep.
So thank you very much, Michael.
Thank you.
And then that's going to be it for now. I hope you guys enjoyed the video. As always, thank you for watching, and talk to you later.
Bye.